Okay, we'll go ahead and get started, and this will be the conclusion of the semester for materials for biology, and I believe this is about where we had left off. We don't have a whole lot to go over. In one of the classes, we asked how many individuals were taking the final. That's what those maroon, red, or purple numbers mean on the right-hand column of the assignment board that you see on the east wall. And the majority of your final is over before the dinosaurs. And we spent a lot of time on them, classifying these animals, giving them characteristics, why they're separate, what do they have in common, are they vertebrates, are they invertebrates, are they tetrapods, are they carnivorous, are they herbivores, materials like that. And reproduction was another big one. Okay. Like I had mentioned, this was one of your vocabulary terms. It was dealing with artificial selection, and what we had discussed in class is the idea that farmers can change this if they so choose. Or you could use this with, I suppose, any type of breeding pair with dogs, with cattle, with, I suppose, you could just take your pick. Reptiles, any one of those, to where you want to take certain traits that are desirable for being selected for breeding. Okay? Now that's different than natural selection, because those that have an advantage then, okay, would be better suited for survival. And that's what natural selection is. It's when these adaptations take place. It's a successful trait that gives that organism just an extra bit of an edge over different types of animals. And a good example of that would be, think of the chasmatosaur. Okay? We know that it has a prehensile jaw, which means it's got teeth sticking out of the front of that animal. Why is that significant? It's just that extra little bit of an edge that allows them to grab onto prey items and hang on. My guess would be is that those animals don't have the same jaw strength as maybe modern crocodiles and alligators. So anytime you have that adaptation for natural selection to take place, it just gives that animal just that much more of an edge. And then you might say, well, why did these animals die off? Well, there could be a variety of reasons in this mass extinction, because at the end of the video they had talked about it was those animals that were large that they just couldn't get past that meteor strike that took place at the end of the Triassic period leading into the Jurassic time when, I got that wrong. At the middle or end of the Jurassic time when that meteor strike had actually hit the Earth. So my guess would be is a lot of their prey items, was it a Lystrosaurus, I think, is where they had attacked those animals in the river when they're crossing to get to the other side. I almost said Scutosaurus. That wasn't right. I think it was a Lystrosaurus. So if your prey items die off, well then you have nothing to eat. So then that's when these mass extinctions certainly take place. So then those that don't have that advantage of that jaw sticking out just that much further, those organisms would die off along with that trait. Okay? So if the trait that has that jaw sticking out that much further, that adaptation then would allow that organism to be survival or to survive. So then, as you can see, that then is passed on to the offspring and the next generation. Okay, and then, so sometimes students in the past had asked, so how do we know that these animals actually existed? Well, It's not because of bone structures that would be left behind. Some of the vertebrates, yes, that's possibly true. But how would you know that Meganeura was around? How would you know that Brontoscorpio was around and all these other animals? Well, they become fossilized inside of rocks. So then that then would provide evidence that these animals actually had existed at one time. Okay, then moving forward. So when we're talking about this here, where it says derived traits, talking about these feathers, that is more what we consider, you could say, a modern adaptation, because why would we state it that way? Well, flight certainly took place. It's actually changed 4 times throughout the fossil record. Began with the dinosaurs, okay? Pterodactyls would be animals that could fly. Insects could also fly. We know that because of Meganeura, so there's 2 times. Then the 3rd time that flight had actually evolved would be with your modern birds like Jerry, as you walk in the room, the owl sitting above the door. That's the 3rd time that flight had evolved. Then the 4th time would be that of a mammal. In other words, the bats. So then when we talk about those in the spring, those are in the order of what we call Chiroptera. Okay? So this classification that we do is also going to be important in the spring when we classify the mammals in their assorted orders. You may remember we had talked about Proboscidea. Okay? Those are the elephants. So class Mammalia, then we go to the order level. Proboscideans are elephants. The mammalian class, we go to Chiroptera. Those are your different types of bats then, whether you could say vampire bat or fruit bat or bumblebee bat, then you're getting into more of different types of species of those animals. So that's how flight had actually evolved 4 different times. Then when we talk about these, we certainly know that teeth, nails, those are a little more primitive, because that's where you're going all the way back to that of the Anomalcaris. That was the first animal that we would have seen in the dinosaur before the dinosaurs. All right, and then we had talked about, oops, I know what I got to do. I got to switch this portion of our presentation, and we said that this is also available in the drop folder, okay, and it would look something like this, where it has all these animals, okay, and we've talked about these before, all right, but then if you want extra practice and say, well, I want to look at these in the drop folder, well, here is the V drive, okay. And if I'm not mistaken, we had done this around the first week of school to show you how to get to the drop folder. So here is, as you can see, the student apps, the V drive, go to drop folders, and then go to this one, and then go to biology, and then we called it 114B, okay? And that is what you could open up here. And you do have that information available if you so choose. Knowing the animal when you're looking at that would be certainly an advantage for yourself. Okay, so we know this is a smaller reptile. So what is some of the characteristics that we see? We know it's a tetrapod, okay, and we know it had evolved with a middle ear bone, and then these teeth are more so for defense. These, I don't know if they're really not canines, because that would be further up here, because when we associate a carnivore diet, it would make more sense to have the teeth up front as opposed to the back. So I think it's more so of a display for reproductive purposes. And yes, it's a tetrapod, and as we had established, it's a small animal. And yes, it's the Dictodon. And some of you had followed along and filled out those phylogeny trees like we had recommended that you do, this will be a lot more simple for yourselves as you approach the final exam. So what do we have here? Let you think about that for a moment. And of course, that's the Petrolacosaurus. So it should be very obvious what type of diet this animal has, okay? Just because it has an insect in its mouth, so therefore we know that this is a carnivorous diet. Then we would want to classify that, well, is it a tetrapod? Well, yeah, because it's got 4 limbs, okay? Is it amphibian-like or reptilian-like? And what we talked about in class, going along the backbone, we can see, okay, it's got all these scales on here. It's got teeth. And of course, the major distinguishing characteristic for reptiles, besides the scaly skin, is having claws. You could say, well, not all reptiles have claws, like, of course, all the species of snakes don't have claws, but when you are making a comparison to the amphibians, that would certainly be a distinguishing characteristic, and that's what we pointed out in class here. Okay, and of course we know this is your Hynerpeton. Okay, and how do we know that? Amphibians are tied to water, whether it's where they live, it's where they hunt, and certainly where they reproduce. They're tied to water, so this is hopefully a decent clue to say reproductive purposes, these animals do reproduce in the water. That's where they lay their eggs, and then that's where they're actually fertilized in as well. So then we move on. Is it a tetrapod? Yes, of course it is. It's different than that of the reptiles, even though the legs are at 90-degree angles. We said the belly is closer to the ground as opposed to its reptilian counterpart. It's still what we consider a carnivore, and when these eyeballs are closer to the top of the skull, we talked about that as well, and this is closer to the top as well, and it doesn't have that brow on here like the Adaposaurus does. So then a distinguishing characteristic, smooth skin, and it's got webbed feet or toe pads or however you want to associate with that. So we know it's a tetrapod, it's a carnivore, and it reproduces in the water. So the next animal, probably the most successful and certainly the, you could say the most dangerous of all of these animals would be whether you say the Gorgonopsid or Gorgonops, however you want to associate that name. Of course, 4 limbs, it's a tetrapod, certainly a carnivore, and this was a blueprint for many modern carnivores as they show up in the fossil record. Now, there's a few reasons for that because of the jawline, we could say, although you can't see it here. But we did in the video. We know that these have very, very large canines. Why is it so fast? Because it's a therapsid. Of course, it's a tetrapod. And it certainly was considered highly intelligent. Okay? And then it had a very flexible pelvis back here. And that's why we would hit pause and illustrate, say, just watch your dog when it lays down. It illustrates this animal lays down the same way, and that's why we categorize this animal as a therapsid. Then we were talking about this earlier. Okay, here's your Chasmatosaur, another tetrapod. Okay, obviously reptilian. And would reproduction be in the water because it's swimming in the water? Well, reptiles do not reproduce in the water. They are terrestrial reproducers. So just like the Adaposaurus and the Dimetrodon that we would have seen in the video. Okay, and this is that prehensile jaw that we're talking about. When this is an adaptation, natural selection is going to choose that animal that has that stick out just a little bit further. Those animals that possess that trait, they pass it on to their offspring, And that's how and why this animal looks the way that it does. And maybe the jaw is just as strong as that of modern alligators and crocodiles. Maybe we're not concerned about that. We just know that this is also a highly intelligent animal because it has memory. It's not the first animal that had memory. We'll get to that a little later. Okay, and then this was the template for all vertebrates. And how do we know that? Because this is the haiku-ethes, or just haiku, however you want to approach talking about that animal. It was the first vertebrate, and it was very flexible that laid the design for, of course, all vertebrates to follow. Then here we have your cephalaspis. They called them shield heads, okay? And this was the animal that first had memory, okay? Because, how do we know that? Well, it would navigate back to where it was born and where spawning takes place with these animals. So, reproduction in water. How many do we have so far? Let's just go ahead and reverse. Reptile on land. Reptile on land. Amphibian. That's water, so that's one. Okay, a reptile, so that's on land. Okay, reptile, that one's on land. Okay, so here's number 2, along with that of the hynerpeton, because fish reproduce in water as well. So then here's the third one, the cephalaspis. We know that because they would navigate their way back to where they would spawn and lay their eggs. Okay, this, remember, we classified as the first synapsid. Okay, and with that, it's a synapsid because of this brow line. Its eyeballs are more so fixed into its skull, and the jaws were starting to get to be more powerful then as well. So how would we separate this Adaposaurus from a Dimetrodon, which would look very similar because they both have sailbacks. They passively regulate their heat. But then it's also a tetrapod, and it's a reptile, so its reproduction would be on land then as well. Okay, one first of 3 arthropods, or invertebrates, the Meganeura, and the only one that we talked about that could fly. Then Brontoscorpio, okay, and in this case, they started out, these were the first animals to get onto land, okay? Now that's a trick question. These were the first animals to move onto land, but the hynerpeton was the first vertebrate to move onto land, okay? So kind of a distinguishing question right there. So what advantages does the scorpion have? Well, we said it's got this stinger, and having venom is certainly going to be an advantage for some animals. Otherwise, that characteristic would have disappeared in the fossil record. But it's important to have that. Scorpions have it, snakes have it, spiders have it, and certain mammals have it. Let's see here, who are we leaving out? Scorpions, snakes, spiders, mammals, and that's the duck-billed platypus that actually has venom in its back feet. I suppose you could say lizards. There's a couple species of, or a few species of lizards that are venomous. Now you might think frogs, but frogs are poisonous. They're not venomous. Okay, so 6 walking legs, so it's not a tetrapod, unlike what we would have seen here, another tetrapod. And then the first animal we talked about, also an arthropod, the Anomalocaris. So what advantages did it have, or does it have? Well, it had the first jaw that we talk about, the first super predator, and we classify it as the first super predator because it had that jawline and, of course, this evolutionary advantage right here, eyesight. Okay, and then moving forward. And then this was the template for dinosaurs. As we can see, this is which animal. And if you would say Euparkeria, you would be correct. Okay? Why is this animal significant? Well, because it could run on two legs like this, it freed up its hands. So therefore, that would have been an evolutionary advantage. So, but still a tetrapod, and its reproduction would take place on land. And still, of course, a carnivore because it would eat other insects. Then we would say that this is the first vertebrate superpredator. Okay? And this Hyneria then had actually illustrated the storyline of attacking the Hynerpeton up on shore. So the first vertebrate superpredator, that of Hyneria. So another aquatic reproduction taking place. So that gets us up to 4 now. We had said the Hynerpeton, the Hycoethes, the Cephalaspis, and now the Hyneria. So that's 4. And then finally, the last animal, also a tetrapod, okay, and has a sailback to passively regulate its heat, also known as a synapsid as well, because these are, you could say, closely related to that of the Adaposaurus, but this, of course, is carnivorous rather than herbivorous, and yes, this is the Dimetrodon then. And I think that is the last one. So knowing these animals, when you look at them, is certainly going to be an advantage because we'll just have numbers on here. It'll just have a number on here, up here, I can't remember which, but there'll be questions like which animal was a therapsid. Then you would look for the corresponding number, and maybe it's number 8. I don't know. I'm just throwing that number out there. And that would be this. If there's an 8 here or 8 here, I can't remember which, because this was a therapsid. It's just questions like that, for instance. And if we were to say, what was the oldest ancestor for vertebrates? Well, who was the first vertebrate? Well, then you'd want to be looking for that animal, because it's the Hycoethes. That set the template for all vertebrates. Okay. So then, who was it that had maybe excellent memory and a prehensile mouth, which means it had teeth that stuck out the front of its jaw? Well, when we look at this, oops, is that going to be able to back up? No. Oh, I can still do, I thought maybe I had to have the presentation open. So we certainly know that it's not this. This doesn't stick out. So we have to look for a carnivore. That doesn't stick out. That one doesn't either. So we have to keep on going until we find, of course, this animal. Had excellent memory and a prehensile mouth. So questions like that. And, of course, when you look at these, we could say, how many total tetrapods were there? How many arthropods were there? Okay. And just questions like that, and we can continue to discuss that moving forward, because I see we are up to 24 minutes. So we will continue to review, and some of you do have the opportunity to opt out of the exam if you so choose. So again, that number that's written on the east side of the wall, that's for a separate section, because as you know, we got 2 sections of biology. We'll continue with this tomorrow. We'll catch up to you next time.